we're going to go through some examples on how to use les, oops, sorry, wrong comma, les hôpitaux, or la hospital, as my students sometimes call it, hôpitaux 0. All right, and this is used to help us find limits when they're in indeterminate form. And indeterminate form means 0 over 0, or if you have infinity over infinity, that's what we're looking for. Now, we're going to go through some special cases where they're not 0 over 0 and infinity or infinity immediately, and where we have to simplify to get them into an answer or in a form that we can use l'Hopital to solve. All right, so let's go through some, and we'll start with this one. The limit as x approaches 0 of 1 over x squared, all right, to the x power. Now, as we see this right here, you notice what we have. We plug in 0, and what we have is 1 over 0, which is infinity, and then we take 0 and put that in there. We have, all right, infinity to the 0 power. Now, that obviously does not work, and that's not the best way to do it. So what we're going to do is we're going to change this up a little bit, and we're going to make this, and understanding that this equals L, okay, we're actually going to take this limit to eliminate that value. We're going to substitute, and we're going to actually log both sides, because we want to get rid of this exponent. And if you ever want to get rid of an exponent, you want to use its inverse operation, which is a log. So I say if you want to get rid of an inverse, you need to log it good. So we're going to take the natural log of both sides. We're going to take the natural log of that limit, and then we have the natural log of my expression. All right, 1 over x squared, that right there. And so what happens, we put the x in front. Now we have the natural log of 1 over x squared, like so. All right, now what we have is we have x times the natural log of 1 over x. And we now can take this limit again, the limit as x goes to 0. And now we have 0 times the natural log of infinity, which then gives us infinity. So we have 0 times infinity, which is not good again. So what we're going to do here is we're going to switch this around again and do a little change-a-roo. And we're going to change this x right here, that x right there. We're going to rewrite it and use a little math magic, all right, and make it into 1 over x, okay, 1 over x. Now, if we take this expression, the limit as x approaches 0 of natural log of 1 over x squared over 1 over x, we now see that, yes, what we have right here is going to be infinity over infinity, okay, indeterminate form that we can use, okay. So from here, what we're going to do is we want to solve this limit using L'Hopital's rule. So we're going to take the derivative of this. So if this was f and we called this g, we're going to take the derivative of f and then over the derivative of g. And what we have then is 1 over x to the negative second power, I just write it like that, times negative 2 x to the negative third power, all over, I'm going to change that obviously to x to the negative first, and we'll have negative x to the negative second, like so. All right, now with this, we can simplify. We're going to try to simplify this. And what we have then is x squared. We're going to have the negative 2 there. We can put that over x cubed. This right here can go to the top, multiplied by, we got another negative, so the negative makes it positive. And then we're left with x squared right there. All right, now as we plug this in here, we notice that we have 2 times x to the 4th over x cubed. And what we have then is 2x. Well, from here, we simplify this expression. And now let's go back here and take our limits. So we have, all right, the derivative of f over the derivative of g is going to give us 2x. All right, so we take 2x, and now we'll take the limit as x approaches 0 for this. And we realize our limit is going to equal 0. Well, that's great, well and good, but you have to recall that way up here, we actually simplified this expression by taking a log, because we had originally an exponent. And that our answer is actually, the limit is actually equal to the natural log of L. So this 0 that we found is not actually equal to L at all. It's actually equal to the natural log of L. All right, so we got to solve for a limit. Well, how do you get rid of this natural log? We're going to e both sides. And what we have is L equals e to the 0. which equals 1. So our limit right here is going to equal 1. All right. So that is how you can take and rearrange an expression where you have infinity to the 0 power, and rearrange it using logs into one of the determinate forms that we know and love right here. Well, let's try another example of this. All right, something a little similar. And let's take this. Let's take the limit as x goes to 0 to the right of sine of x tangent of x. All right. Now, as we have this one, we're going to plug this in because we're looking for if it's an indeterminate form. So I plug the sine of 0, and that's going to be 0. And then I take the tangent of 0, and you realize the tangent of 0 is 0 as well. Well, 0 to the 0 power is not equal to 1, even though you would like to think of that. But it is not. And it is not in an indeterminate form, 0 of 0 or infinity of infinity. But can it be? Well, notice that, once again, we have an exponent with an x and a base which x. And to help us solve this a little bit, we can log. All right, log this expression. So that's what we're going to do. We're going to log the sine of x. And when I do that, the tangent goes in front. And once again, if you recall, just like in the previous problem, all right, this is actually going to equal an L. So what we have for our final thing is going to be the natural log of L. Okay, so you have to remember that as we get to the end of this problem. All right, so now we rewrite our expression. We'll just test it out one more time. On our right, we're plugging in 0. And the tangent of 0, once again, is 0. And we take the natural log of 0, well, that's undefined. And actually, to the right, that's going to go to infinity. So we have 0 times infinity. All right, so almost there again. All right, so we don't have anything we can work yet. But like we did before, we can rewrite this as natural log of sine of x over 1 over tangent of x. All right, remember tangent of x, which actually is cotangent. All right, now when we have this one, cotangent of x right there, and when we plug in 0 into cotangent, we realize that we have infinity over infinity, because now we take the limit as x approaches 0 to the right again, and now we have an indeterminate form that we like and we can use. So from here, we can use a l'hôpital. All right, so when you're in trouble, an indeterminate form, who do you call? A l'hôpital. All right, so we're going to take the derivative of the numerator, so we have 1 over the sine of x times the inside, which is cosine of x, using the chain rule. And then the bottom, we have cotangent, which can give us negative cosecant squared x. Okay, and we will rewrite this a little bit because it probably can be simplified. And with this right here, we're going to have sine squared of x, because that's where this will come, as we have a negative there. All right, because 1 over the cosecant is going to give us sine squared. And then we have times cosine of x, and then sine of x. All right, well, you notice that this can cancel out with that. We can turn that to 1. And now we'll take the limits of this new expression as x approaches 0 to the right. And we plug in 0 into sine. That is 0 times cosine, which is 1. And we get an expression which is 0. That's a very common expression we have. But we realize that that is not the actual value we're looking for, because we realize that, hey, that was actually natural log. So that 0 that we found is actually equal to the natural log of L at 0. So how do we solve for L? E both sides, and L equals e to the 0, which equals 1. And that is actually our limit. Okay, so those are 2 examples of how to find limits in different, or rearranging equations, special cases where you need to get indeterminate form. This one was infinity to the 0 power, and this one was 0 to the 0 power, and how you can rewrite that using logs. Okay, hope that helps, and look for my next tutorials.